steps for inspection. The first step in the process is to complete an electrical application form and to indicate what type of inspection is needed. Step 2, a voucher is issued of a related amount to be paid. You take the voucher up to Victor E. Bruce Complex, and this is where the voucher is paid, and you receive a receipt. You return here, and a date for inspection is given. After the date is given, the inspectors go to your site and examine the electrical installations. They also register the information on a card.
What we are doing today is we call a mains inspection. Alright, this is the splitter area, we call it, and you have your 2 meters here. You have to check every point. This is the gland that connected here to the house, and it's slack, so the guy gotta fix this. This is broken. It's supposed to have this square to be protected. Right? It is tight and good here, but it needs to be protected by having this properly sealed. Final inspection where you have to have everything in place. All the breakers here and all the information on the installation of your whole installation, where every plug is must be registered here. Right? But right now this is the mains only, and it's only valid for 3 months. Alright? After 3 months, we expect you to have a final done. If not, you make an application for another 3 months. Means it's a temporary measure. But what's happening? People does apply for the mains only because they want to use the current to do the drilling and stuff. So we provide that, so they could do their thing. So it's always better to have current on the building when you're doing final inspection. You don't expect it to have your pipes in and your boxes in without stabilizing it. Because when the guys come to plaster, it must not interfere with the box. You want the panel where everybody could be accessible to it. All the conduits must come into here and distribute to all the walls. Plugs, counter height, above your counter. Everything is connected back to the panel. You have outlets here so that they could do their work. Right? It's valid for 3 months. They could continue as the building is building, because you know people need their current to do their cutting and stuff. So we call this a temporary installation. What we just did there was a preliminary inspection.
This stage of the inspection is where we are testing each individual circuit. Right? The breakers in the panel, each of them control a circuit. So we call them circuit breakers. And what we're doing now is a polarity test. Now the 2 lights will indicate a correct wiring of the wiring device or the socket outlet, what we normally call the plug. So each circuit is being tested individually. An important element of the inspection is to do a visual. It's the visual component where you will look at the workmanship. You can pick up a lot from that, right? The job is expected to be carried out neatly and professionally. The devices must be properly secured. We'll go to the panel and I'll do several tests that also must be satisfied. And those are really the crucial ones, because that will determine whether or not there is electrical shock or fire, which are basically the 2 components we must satisfy. Those are primary. Safety is that it safety to life and property must be observed. So we don't want people being killed, electrocuted, shot, and at the same time we don't want property being destroyed. So those are the two essential factors to be considered when you're doing electrical work. The regulation we have for commercial buildings, we don't accept at 115 volts, which is how most lighting is wired. We don't accept more than 8 lights on a circuit. If it's domestic, we accept not more than 12. But of course, all of that is subject to how much current is on the circuit. The inspector can use, or the inspectorate can use discretion with that is concerned. So there's a neutral connected BAM. 394, 433, we good. Alright? So I'm going to the other phase. Quite simple. We're good. Alright? Main breaker is off on the inside. So I can ring here. This is the apartment we are testing face to face. That's good. Okay.
All tests conducted by the engineers, installation, and all the various tests that would have conducted with regards to the oil samples, the dielectric testing, the hypot test, the insulation resistance test, all must be witnessed and confirmed by the electrical inspector.
Do an oil sample on this transformer. As today we're doing an annual maintenance on this transformer. Normally we just take our oil sample and this is the bottle here. We just bake the bottle at a certain rinse it out and bake it at a certain temperature. Right, and after when it baked, we come and cool it, and when we go in and take oil sample on transformer, we just use this bottle. Firstly, we clean around the pot where we taking the oil sample, and then when we clean it, we take the oil sample. Put a spill mark on the ground because we don't want the oil to fall and spill on the ground. First, after take a little sample to rinse out the bottle. We just rinse out the bottle twice. I take it, I close the cover, and I rinse it out. So I put it in this bottle here, and now I'm taking the sample. After we take the oil sample, we just take a temperature because we want the temperature of the oil. So that we can make a calculation, the age of the transformer, how long the transformer, life of the transformer. So we take this temperature. The oil does go to the lab. What we does look for in the lab does look for is dielectric strength, moisture content, and acidity. Right? Like the 3 tests mainly we does look for it in the oil.
We conducted testing at Lowlands Mall, Tobago. Well, when we just did here, we ended up doing the transformer. We did an insulation resistance in the transformer, and we took an oil sample, and we did a ratio. The insulation resistance, we did it at 1,000 for a minute, and we did 5,000 for 10 minutes. Then we took the oil sample, and we disconnect the LV cables firstly to begin, and the HV cables, and we did the insulation resistance, as I said.
The electrical inspectorate also verified the physical surroundings of the transformers, switch gears, and also the other areas on the compound that relates to the high voltage system. A final documentation is sent to the chief electrical inspector, who would then issue a certificate for the high voltage.
The electrical inspector is to ensure that rods are driven in the 4 corners of the transformer room. This area is all properly done to in the event that there are oil spillage or even water leakage within the system. We are also to check the entire physical aspect of the transformer room. Things like proper ventilation. This is to allow the transformer area to remain cool and not being too hot with regards to the transformer windings within the installation. We are to check for the cable tray in which the cables are run to make sure that they are done in a workman-like fashion and properly secured within the transformer room. Metal hooks must be earthed. Go back to the general master of earthing. This is to ensure that non-current metal work must be at zero potential within the transformer room. We are also to ensure the structure is properly done. There is concern with regards to leakage of water within the transformer. Lighting must be efficient, the level of illumination must be good enough to have the work done in an efficient fashion. So that all the signs are placed on the transformer room, switchgear room, and other low voltage room to indicate that there is danger. Transformer area must be isolated at all times. It is only open only when the supply is disconnected to the transformer room. Because of the seriousness of this installation, all signs, danger 12,000 volts, isolate before entering, must be placed on all transformer room, regulator room, high voltage regulator room, and switchgear. This is to indicate that no one should enter because of the seriousness of this installation. Termination, the lugs must be securely anchored and ensuring that there are no slack connection, as this could result in dangerous arcing. This switchgear has all the electrical connection within it. All the current carrying continuity of the supply voltage of 12,000 volts is stored within this switchgear. This switchgear is this apparatus. It must be insulated, isolated from any from members of the public. Right? The earthing is essential on this installation, as you see driven rods, and the Inspectorate must ensure that all rods, all connection earthing conductors are properly terminated, and all metal hooks on this apparatus or switchgear is securely connected. The report of the testing engineer along with the report of the electrical inspector on the project must be handed to the chief electrical inspector. Once the chief electrical inspector is satisfied with all reports, the chief electrical inspector will prepare a certificate, a high voltage certificate for the particular installation. Only the chief electrical inspector is the only person to sign that certificate.
The inspector returns with the card, and it is given to the clerk typist to write or type up a certificate. But work continues here. We have data. All the data on the card will be input on our computerized system, and then all this information is filed away.